everyone, and welcome to After the Award, where we talk with the Isaac awardees about their journey since winning the grant. And so, just to get started, I'm going to ask if you can just give me your name, the institution that you're connected to, and the year that you won your grant.
My name is Joshua Vaughan. I'm a professor of chemistry at the University of Washington. 2022.
Why did you apply for the Innovative Science Accelerator Program grant? What was the kind of driving force for you? Was this something that you had never seen before? Just tell me a little bit about your experience leading up to the application process.
Yeah, well, I had a new idea and it was a bit risky, and I needed to get some preliminary data. So it seemed, on kidney, we can talk about it in a little bit probably, with mapping out glomeruli, filtration units. And it seemed a bit risky for traditional NIH mechanisms, and that are sometimes harder to get with the riskier element of a proposal. So I thought this would be a perfect vehicle to try and support a new risky project. And luckily we were able to get the funding.
Thank you for sharing. So, what progress has your idea and just the project as a whole? What progress has it made since receiving the grant? Have you guys been able to publish? Have you, been able to have your work peer reviewed? Where are you? Where are you now with it?
Sure, yeah. I had a wonderful PhD student who worked on this project, on this Isaac project, and he was able to publish his work last November 2025. It was featured on the cover of Kidney International, so that was pretty exciting. So he got a pretty splashy paper, and yeah, so we've got some attention from it, and it was all seeded from this Isaac Award.
That's a pretty big feat. That's pretty amazing. Since being awarded and everything, and even your PhD student having that feature, have you all received even like more press from even that feature, or just recognition amongst your peers in this particular in the kidney space, or even the KDH?
Yeah, it was more recognition amongst peers, and I think as somebody like me who's not trained as a nephrologist, or I'm not also not a doctor in this space. So I'm a basic researcher, but moving into the kidney space, it's been really helpful to be able to publish some papers like this one in order to get recognition of our contributions, and to hopefully help us get some more funding down the road.
Well, you already are kind of touching on my next question, which was, where do you see the future of this idea going and the work that you all are doing in this space? But if you can just kind of give me a little bit more on what you kind of the end goal that you see with this project.
Yeah, the end goal, I think a great next step that we're working towards. We've got some pending funding on this for a new project, which would be to extend the work from the Isaac project. In that project, I'll tell you just a little bit about it. I'm not going to geek out too much, but we took mouse kidney tissue sections and we imaged the glomeruli at very high spatial resolution. These are the little filter units of the kidney. In mouse, they're about 75 micrometers. That's about the width of a human hair. And we really want to extend this to humans. It's much harder to image the human glomeruli because they're much bigger. They're about 4 times wider, which in the volume sense is 64 times bigger. So it's a couple of orders of magnitude larger problem to map those out at the same detail that we did for mouse. But we've got a new angle on how to do that. And we think this could be a really powerful way to provide us with very rich data sets that can map out all the different cell types and perturbations, or just the normal physiology of the human glomeruli filtration units. We also have a project with a very talented collaborator, and they're Ying Zheng at University of Washington Bioengineering, and they're trying to bioprint realistic glomeruli models. So that would be using various fabrication techniques and then colonizing their fabrications with cells, and then using that eventually to create like in vitro systems that could be used to test drugs without requiring animals, and of course not using humans. In that case, it would be all in the test tubes, proverbially speaking. So those would be a couple of directions that we think our work is contributing to or headed.
Awesome, awesome. And when you applied for the Isaac grant, what stood out to you about this grant that was different from the other grants that you have applied to in your research tenure?
Well, it's really the one word, which was risk. They said we want ideas that are riskier, and if it's not risky enough to be something that NIH would avoid, then it probably wouldn't be a good fit for Isaac. And so I thought about it, and I've always got a bunch of ideas poking around in my head, but in this case, that particular idea for mapping the mouse glomeruli in this way, I realized it was going to be a tall order for NIH. So again, it's just the willingness to accept some risk. And I think a lot of times the long-term payoff for riskier projects can be higher than the long-term payoff for the less risky but perhaps more easily funded ones. And this might be an example of that, where something that was a bit risky paid off and has yielded quite a few dividends.
Thank you so much for sharing. I think that really helps give kind of just a really good perspective on really what the heart of the grant is, high risk, high reward, and um, speaking out ideas that haven't been, either they have been introduced or they just haven't been introduced in the way that those who have won the grant introduced it to us. But my final question to you is, what advice would you give incoming researchers in regard to applying for grants, even for grants such as Isaac or grants, other grants that are out there? And then a two-parter to that is, what advice would you give them for just finding their way in their scientific research journey? Anything to kind of help them in the process?
Yeah. Well, personally, I feel like I'm still seeking advice on many of those things myself. Perhaps a couple of my own reflections, though. So, grant writing is hard. Funding rates are whatever, maybe 10% or less for a lot of the funding mechanisms scientists apply for. So you got to get ready to get rejected and keep trying. I think it's helpful to cast a broad net. A lot of people are reluctant to start with bigger mechanisms. I've done big and small mechanisms. Isaac is a smaller mechanism. I think it's great to use a mix of all of those things and to treat the grant writing activity as a process where each proposal you write, you're hopefully developing new ideas, and maybe if you don't connect on that one, maybe you're going to retool it and perhaps combine it with a new twist or angle or idea and send it back out. So treat the process as something that you iteratively improve as you go along. It's good to have a portfolio of ideas that can be developed or tuned for different purposes. And I think having some safer ideas for some mechanisms is great, and some riskier ideas for other mechanisms, such as Isaac or sometimes foundation work, we've had some success in that space, can be really nice. So I think having a range of ideas that you could move forward with, depending on how the funding goes, is really powerful. That was, I think, the first part. Can you remind me the second part of the question, Kanisha?
Yeah, absolutely. Just what advice would you give individuals who are just trying to find their way in their scientific research journey?
Okay, got it. Several thoughts occur to me. I guess one that I've reflected on a bit lately. So I've been a professor for 13 years, and things have gone well. We've published lots of papers, and we've gotten funding and graduated lots of PhD students and postdocs. I've got a postdoc who's recently accepted started as a faculty position at Indiana in nephrology and pathology. So that was really gratifying. So some of the things that some of the principles I've used when I make decisions, plans, and such have been really to just look for things that keep me really excited and that I think will be impactful. In a way, to march to my own drum, I think there's a lot of there's a lot of people giving advice. I'm giving some advice here, but there's a lot of people giving advice. Say you should do this, you should do that. Everything needs to be a certain way. There's no, there's no value in research that's not hypothesis driven. You must conform to this mold. And I would just say that I like to do things that are sometimes discovery based, and this can often be more risky, such as on the Isaac project and a couple of other of my funded projects. So I would say don't be afraid to go after the things that you're excited about, even if it may not conform to somebody else's expectations. Science is hard. We face a lot of challenges, not just the funding process, but the actual science is hard. So a lot of times, just making your way through that. And I personally think it should be really exciting, and that should be the key motivation. That's the thing that drives me and gets me out of bed in the morning. It's like, this is exciting. How cool is this? We get to go discover or invent a new thing. And trying to follow somebody else's expectations can set you up for a less happy career, a less exciting career. So yeah, but that needs to, of course, be balanced with some practicalities. What if you're excited about something that's very obscure? So hopefully one can balance those, one can balance that idea with something that's also practical enough. But I think march to your own drummer, I guess, in short.
I think that's valuable advice that could apply to any field and, any job that anyone is doing. Well, for the most part, internally. But I just thank you so much, Dr. Vaughan, for sharing all of this insightful information. And that will conclude our After the Award interview.